I know it's always hard to talk after a break, but I think we can handle it. For those that don't know me, I'm Martin Levy. I'm at a company called Hurricane Electric. We have been doing IPv6 for an awful long time, and there's a couple of different things about our company that may surprise you about what we're going to talk about. One is we're known because we run a large amount of internet backbone traffic and a large amount of v6 traffic. But as a company, we're also a pretty good group of software developers. In fact, one of our requirements to be a network engineer inside Hurricane Electric is you also have to be a software developer. And we do this for a couple of reasons. But the biggest reason is it means that all our network developers are also tool developers. It means that they don't do the same thing again and again. They actually go and write software to essentially make their life easier. And writing software and building tools is a very valuable thing when operating a network. Now, what comes out of that is a level of expertise about the subject that we're here today to discuss, which is IPv6. Because it would be pretty embarrassing if we were writing software in-house that actually didn't speak IPv6, being that we spend a lot of time evangelizing it. So what I'm going to do today is I'm going to deal with the software development side and, in theory, show how easy some of this work is. Normally, this is Owen DeLong's talk. I'm actually using his slides. But I can honestly say, quite qualified at talking about software development, even though that's not what I normally talk about. Hold on. Let's get a bit of mobility here. Okay. Well, we've already seen this. But you've got to realize that if you're talking to software developers, this may not be obvious. They worry about building software. They don't think about the big picture. They think of connecting to addresses and to host names, and they're not maybe aware of the IPv4, IPv6 story. So this is always in there, and it's always good to remind yourself of where we stand. But this was discussed yesterday. Second problem, there's going to be an awful lot of text. Coding is like that. All right, so where's the problem? Let's go right into the middle of it. It's so simple. I know that this projector has been well stressed over the last couple of days. But the reality is this. When you get an IPv4 packet that has a source address and a destination address, the size of that packet, the size of that header, and the size of the address field is 32 bits. In the software world, when you jump up to 128 bits, which is what you're doing here in a v6 header packet, 128 bits does not fit into 32. And that is pretty much the summary of software development issues with v6. Everything else I'm going to talk about is going to talk about how you get around that problem without having your software blow up, right in the wrong places, etc. And the good news is that this is something that's been well understood, but the subtlety of writing code is such that if you had written socket TCP/IP code in C, and let's say you'd written it when I started writing it back in the mid-'80s, that code would still run today, but it would only be v4. So I'm going to talk about the differences between v4 and v6. All of the code structure here, I'm going to give you a couple of URLs later, actually in the next slide or so. If you can't read the code, don't panic. It's all online. So the URL is there. It's Owen's URL for all of this sample application code. But I'm going to talk about some of the simple things that need to be done code-wise. So a couple of very important things here. You're going to see the number 6 show up in various places. You're going to see the fact that there is a fair amount of work that needs to be done in editing and changing, but when you finish, the reality is you're back to classic software issues. You're going to have to write code. You're going to have to debug it. You're going to have to change it. You're going to loop around again and again. So let's talk about some of the simple changes. I'm going to go through a couple of languages, C, Perl, Python. Not going to touch things like Ruby, although it turns out to be very trivial. These days, it may actually be very hard to write Ruby code that is not going to work with v6. It's pretty cool, actually. So the number one change that you'll see, and you'll see this repeated throughout, is the fact that the area that you kept an address, the sock adder structure, has a name change. And it has a name change with the number 6 at the end of it, which is really telling because it says that when the original code was written, they didn't think about the number 4. IP was just IP way back when. You're going to see certain changes and certain function changes as we go through this. But I'm not going to deal with coding examples to deal with things like linked local addresses and some of the other subtleties that you'll get to after this code works. So let's look at the code and actually sort of say, you know, let's actually talk about what we're going to do in this, where we're going to find the space for 128 bits. So this code, this structure that you're seeing here, is the modification for the existing TCP/IP code that originally, if you take it back to its beginnings, was created at Berkeley, UC Berkeley, as part of the BSD software base. It has ended up pretty much structure unchanged since 1983. In most software packages, you'll see this inside Windows. You'll see it obviously still inside a modern BSD, like on a Mac laptop. You'll see it inside a Linux kernel, et cetera, et cetera. But the reality is in the v6 world, what you're seeing here is an IN6 adder being used. And the subtle difference here is obviously that it's 128 bits. There's been some movement to come up with a more generic way of dealing with this. But as you'll see in the code base, that really isn't going to make much difference. Things that I'm not going to talk about. Applications are big. Software bases are big. Keep in mind that you're going to have to go search through your own code. If you're finding stuff where you're putting an IP address into a log file, that IP address is going to change. If it's in ASCII, it may be a set of numbers, 1.2.3.4. That has a maximum length. If you sort of think about it, the maximum length in ASCII is 3 characters and then a dot, and 3 characters and a dot, 3 characters and a dot. If I counted this up right, and then 3 characters. So the reality is that the length of that is only 15 bytes in ASCII. With a v6 address, you could have 8 lots of 4 hex with 7 lots of colons in between it. That's a lot larger. If you store it in binary, obviously we already have talked about that. There's going to be 128 bits versus 32 bits. Other things that you're going to have to look at. I mean, this is no different than somebody deciding to support a town or a city name that's twice as long as an existing name in a database. The code examples here are going to deal with the fairly simple things of TCP connections, which, by the way, are very similar to UDP. But if you start looking at writing complex application code, like writing a brand new trace route, for example, then you're going to deal with ICMP and other functions like that. There's lots of example code out there. That was the reason why we put all this together, just so there was one simple reference place. We were very explicit about the way we wrote the code, a little bit more so than necessary, because the goal here was to make sure you understood where there was v6 and v4 code. So there's lots of v4 underscore and v6 underscore inside the code examples. The URL is splattered through this presentation many, many places, and obviously this will be online. All right, so let's talk about the easy stuff for C. I mean, the reality is that if you have working code, if you're going to look at doing v6 and enabling it, and you've written code in C, it's good old legacy code written way, way years ago. The question is there much support? Is it easy to do for v6? And the answer is yes. One of the most important things that you're going to end up with is realize that the address, because you're coding things in C, because C is very bit, byte word related. Everything is very specific. That you're going to have to search for everywhere where you're using the SYNADA address, where you know you've only got 4 bytes to play with, and you're going to change that. There are various calls that have different arguments. But the good news is that there's also a new set of functions that make life a lot easier. So as much as you have these underlying functions that need to have additional bits in them, the reality is if you look at the code, you'll realize that there's a whole set of helper functions. And one of the helper functions that you're going to look at, INET enter A, INET enter P, you'll see that in the examples of how that changes. So here's some interesting things that get a little bit hairy. Left as an exercise for the reader, you'll find there's things like get IP str, which is easy to find with a Google search or any other search to find out where that code is. Most of the helper functions are by design meant to reduce the amount of code. However, as you look at the examples, you realize there's some subtlety in the way that v6 actually operates. Woo. Went way too far ahead. So basically, one of the subtleties is that when you deal with v6, you're dealing with 2 address families, the v4 address family and the v6 address family. The code has to handle both of them, and you want to make sure that if you're going to make a connection, that you decide which address family, so to speak, on the fly. All right, so again, URL for the code. There's a lot of code that's coming up. If you can read that, you've got good eyesight. And so I'm going to just read out a couple of lines and run through this, but you're going to see some very simple examples. This is how code used to be. This is as good a code as it used to be prior to v6. Of course, it will still work today, but it'll only connect on a v4 connection. You're going to end up being able to take a simple name of a website, let's say example.com, convert that by DNS inside a library. That's where your get host by name call comes from. And you're going to end up selecting and setting up a socket. And you'll see the INET adder call down at the bottom there. These are actually in red. And I'm realizing looking at this that in fact actually it's very hard to read up there, but you'll see more of them. So again, get served by name is going to be the same call that you've seen in v4. So now let's look at what happens in a dual stacked environment. And in the dual stack environment, what you're able to do is use different functions. You're doing get adder info. It's returning a lot more information. Because when you ask to get example.com and say, give me the IP address of that, it may come back as a v6 address if a quad A record exists, or just v4 if an A record exists. And the return value is now going to be multiple families as well as multiple addresses. In the old days, even example.com may have more than one address. But the reality is it now may have more than one address and more than one family. So how do you use this? Forget the IPv4 code. We won't talk about that. But we'll talk about the new way of doing it. And as hairy as this is to read, it really actually has one key function. Everything that's coming to operate inside this code, different than before, is now sitting inside a for loop, because you now have to scoop through this again and again and again, wondering which family the address is coming from. So instead of the old code, which always implied v4, always implied that you would just simply generate a socket with a family type of INET, you could now do an INET 6 instead, and that's going to come out of the address space. As I said, there's easy parts and there's hard parts. If you look at the way the client works, the way the client is going to do a connection, get adder info is also the same code that's going to give you the ability to give you this v4, v6, A, or quad A. Okay, we're going to swap languages, so I'm giving a little bit of a break here. Just a reminder that sometimes things don't work. If you have a v6 client trying to talk to a v4 server, bad things will happen. I actually don't know where this picture's from, but I do love it. Okay, let's talk about Perl, because guess what? We're going to start seeing some duplicate issues going on. But Perl is a higher order language than C, so things are going to get a little bit easier. The use of socket 6 as the include, the use function versus just socket is the first clue. Of course, you're going to have to include the basic socket include as well as socket 6. The get by name functions, all of the various ones which in Perl are very analogous to the way C is written, they get to change as well. And because Perl, although it's a higher level language, still has a large amount of parameter pulling in and out of all the different functions, you're going to see some of the same changes. All right, so get adder info, exactly the same code, because the Perl code is matching the C code in this case. That's really nice because some of the same examples, some of the same methodologies in Perl are going to be used that you see in C. There are some gotchas. Of course, Perl is just a different structure language than C, but you're going to return information and parse it in a slightly different way. So let's look at the old way and the new way. And the old way is, of course, very simple. You could write code literally just line after line and get connections. But in the new code, you may not, this may be hard to read up here, but what you're doing is, the important part of this is that there's one line here where you're looping around, in this case, looking for the v6 address, and you're going to pull out the family and the address and the name, etc., that's coming out from the resolution above of getAdderInfo. GetAdderInfo is returning multiple, if there's an A in a quad A record, multiple pieces of information. This code was written, the examples that are online were written to find if there was a quad A, a v6 address associated with the DNS name, and if there was, to actually do the connection. Again, you go look at the type of changes here, and you're going to see that the simple changes, if you're manually coding up the family, you go from INET to INET 6. This may be very obvious, but again, pulling that out code-wise and making sure that it truly is capable of being placed in the right part of your code means the Perl code will do connections over v6 as well as v4. Very sensitive keyboard here. The last things is, again, to show you the same in Perl that we saw in C here. You're seeing the getNameInfo calls. You're seeing pretty much the same generic style of code, INET 6 versus INET. Very simple changes. The code to print out addresses, pretty similar, and should enable you to be able to handle, if written correctly, v4 and v6 within the same code base. Okay, so the client side, if you're writing client-side code for Perl, the same thing. You're doing socket 6 as well as socket for the use to get all the includes in there. You're handling INET 6 if you see that. Because the protocol family is both the address family and the protocol family is going to change on a case-by-case basis with a caveat. So the way that the original socket code was written way back in the beginning of time, there was no concept that you would ever change the protocol family between socket calls. Whereas in the v4 code, you could reuse the same socket independent of who you were connecting to. Now, a lot of people didn't do this, but it was totally legal to do it. Open up a socket, connect somewhere, disconnect it, close or not close the socket, reuse it to connect to somewhere else. If you're changing the protocol family, which v6 is a different protocol family than v4, even though it's also a different address family than v4, then you have to close the socket and reuse a new one. So there is some code out there that probably loops around using the same socket just to connect out again and again and again, or listen again and again and again. And that now has to change, and there has to be code that's v6, a v6 socket, a v4 socket, or you close it and generate a new socket. 20, 30 years ago, it was, well, 20, 25 years ago, this was not a bad thing to do because you wanted to optimize the usage of your CPU. In the reality, I think that the iPhone in my pocket is more powerful than the average massive VAX computer that used to be used way back when, speed-wise. So we don't really have to worry about this from an optimization point of view. Again, there's IPv4. These are all online. The IPv4 example has everything hard-coded in. On the v6 side, you're going to see exactly the same loop right at the top here. We've got a slightly different loop, but it's the same concept. You know, while there's still 5 entries left in the results from the query, go pull out the family, the protocol, the address, etc., and come on all the way down, trying to generate the socket, in this case actually looking at the PF based upon the address family. And then finally, if you succeed and connect, then actually exit the loop. This is pretty easy code. It looks pretty horrible, but the big difference here is that the code is now saying, I don't know whether I'm going to get an A or a quad A back from DNS. So the code is a little bit more generic. Yes, it's a little bit longer, but the reality is it'll handle a lot more situations. All right, there's lots of different ways to interconnect, but this is really the clue for, we've talked about lots of different things. I don't need to talk about DS Lite, which was always useful to discuss with, and other things to discuss with programmers, but we'll move on to another language. So we're going up the tree here, although some people don't think going Python is up the tree, but we'll pretend it is today. So again, same type of issues with Python, but life gets even easier. And it gets easier because if you look at the difference in the code really here is socket get adder info is basically just the more generic way of saying, I don't care what the address family is, return me all the information, and I'll take that information and can connect appropriately. So again, we end up with what looks like very familiar code. We're doing the same thing. We're going to be different language, same concept. We're going to run a for loop around all of the different results that get returned, and we're going to try to connect, and if we connect, jump out of the loop. Boy, this gets very repetitive very quickly. The language changes. You know, here we are with Python with lots of spaces at the beginning of the line, if that's your thing, and you're going to end up with exactly the same concept. Let the resolver tell you whether there's an A or a quad A. Decide, pick the language, pick the family based upon that. Try to connect on a socket and exit out of the loop once you connect. The subtle differences are that addresses in v6 are not quite what you think they were in v4. We've talked in various times over the last couple of days about the security aspects of different things you can do with linked local addresses and the like. But when you're a programmer, you have to realize that you actually now, in the v4 world, just had an address. In the v6 world, you actually now have an address that could also have a flow value associated with it. It can also have a scope. In other words, it could be an address that's a linked local address that's only available on a local area network, or it could be an address that's available globally. All of that information is given to you, and because you're in a higher level language, the code becomes much simpler, much easier to pull out all of that information. Before, the old way, the v4 way, the simplistic way is that the address simply would give you the host name and the port, the only 2 pieces of information you needed to know when someone connected to you. But now you can actually get a lot more information if you're in the v6 world. Okay, clients. Again, we're starting to sound very repetitive at this point, but that's actually that's the point of this. The client code is amazingly similar as well. Whereas the old way was simply saying, hey, for every address that gets returned by DNS, let me see if I can do a connect, and if I can, I'm finished. The new way is that I now need to understand what my address family is. We do end up with a little bit more code, but the code is now a lot more flexible, and the connection can then be built, whether it be to a v6 or a v4 server. The value of this in Python, the coding value of doing this in Python is no different than in any of the other languages. The syntax, the way that the variables you use are the only subtle differences. And again, if you want to try this at home, all the code is online. I don't think there was anything else on the Python side that I needed to mention, except for my personal disdain for the language. Right, okay. Getting back on track, so the last things here is a quick review of the type of functions that you have in use today, whether they be in C or Python, Perl, and then here what you've got on the new functions. Pretty much most of them are going to be the same with slight parameter changes, but the reality is that these changes are all backward compatible. These changes will work just as easily in the v4 world. In fact, they must work in the v4 world from a testing point of view. Certain structures, this is where, more so for C programmers than anything else, but this is where the subtlety, if you've got much more complicated code, that you're going to have to look and make changes. You're going to look at the sock adder and changing that to sock adder in 6, and you're going to look at changing the address info, which is really less to do with v6, but cleans up the whole sort of legacy code that was essentially developed 27 years ago. I did not mention this, but again, it's a quick Google search to look at it. Sock adder storage is a named structure which is defined in RFC something or other. And it says, well, we shouldn't really be even writing code that's v6 related. We should actually write code that's even more generic address-wise, and therefore not have a v6 or a v4 type structure. We should have just a storage of an address structure. Not a bad idea. Pretty much all the code you've seen will work that way. A quick Google search on sock adder storage will give you, more than you want to know about this. Okay, final slide, near final slide. Let's remind ourselves what we're going to end up with if we do this. Today, we deal with clients that write code and connect to servers, or servers that write code and accept connections from servers. If we're dealing with a pure IPv4 world, we sort of expect global connectivity. If it's there, it's there. If it's there, it isn't. But the reality is that we have multiple situations that we can deal with in the v6 world. Boy, I'd like to sit up here and say life is simple, but no, life isn't simple, not when you get to the operational side of things. So you have multiple different ways of operating, which if done right is done from the identical code base. You have v4 talking to v4. You have, and some people have talked about this in the last couple of days, potentially got a v6 environment that actually does not have global connectivity. So as much as you have a v6 address, you can't talk to something somewhere else with v6. Now, the same can occur with v4, of course, but the reality is that this is the one that you want to be careful of and code around. You could have a v6 client talking to a v6 server, but the reality is that that v6 client is sitting in a 6-to-4 or a Teredo environment, somewhere where there is no direct native v6 connectivity. Or the v6 client could be native. It could be sitting on an address that has a direct connection, not via some form of translation relay over to the server. So all of these situations, and I put the addresses on here just to remind you that you can actually code this into the client if you really wanted to. You could turn around in a client and say, I want to connect both on v4 and v6, and I'll work out which path is the best path. Because maybe I'm still sitting in a Teredo world and I don't want to prefer v6. Or you could code the other way around. You could always code to prefer v6. The code you saw the examples of here was simple loops. Simple for every address that the DNS resolver gives me in whatever order they return, let me try them all until one succeeds. But keep in mind that you actually have the ability to be a little bit more careful than that. You can put extra code in there. You could decide, okay, I want to try all my v6 addresses first, which is what the RFC says, and then my v4 addresses. or I want to try all the v6 addresses that aren't Teredo or 6-4, et cetera, et cetera. All right, so let's summarize what I talked about here before you head home and update thousands of lines of code. So the reality is that well-written code will run for v4 and v6. And yes, if you've got code written 10, 15 years ago, it's not going to be v6 compatible for these type of languages. But if you look at some of the new modern languages, for instance, why don't I need to give Ruby examples? Because Ruby is such a high-level language that you just don't see any of this code. A modern being the key word, Ruby environment will in fact actually do a connection over v6. I have not talked about database or logging code. This is really where a lot of people find serious issues, things that they have to work on. No surprise there. And then the last part is the URLs are on here. I'll make sure this gets put up with Ed's help online. Then you'll have all the example URLs there, and the code is obviously very generic and easy to copy. Last time for the URL, or for a copy of these slides, and Owen's contact information, ask him about the programming information. I'm happy to answer it, but I've sort of now started to use more modern languages and realize that I can get away with nice, easy code. But thank you very much, and if there's questions, I'll go for them without a problem. Yeah, sorry, actually that's a good point. There are various different links. Let me go find you a good slide here. It's all the way back. That one. Yeah, so just the /IPv6 URL, there's actually more information at this URL. There's other examples. You can get to all the sample code, some of the presentations, et cetera, et cetera. Thank you.